Chapter 9. Some applications of trigonometry. Introduction. In this chapter, you will be studying about some ways in which trigonometry is used in the life around you. Trigonometry is one of the most ancient subjects studied by scholars all over the world. Trigonometry was invented because its need arose in astronomy. Since then, the astronomers have used it, for instance, to calculate distances from the Earth to the planets and stars. Trigonometry is also used in geography and in navigation. The knowledge of trigonometry is used to construct maps, determine the position of an island in relation to the longitudes and latitudes. Heights and distances. The line of sight is the line drawn from the eye of an observer to the point in the object viewed by the observer. The angle of elevation of the point viewed is the angle formed by the line of sight with the horizontal when the point being viewed is above the horizontal level. That is the case when we raise our head to look at the object. The angle so formed by the line of sight with the horizontal is called the angle of elevation. The line of sight is the line drawn from the eye of an observer to the point in the object viewed by the observer. The angle of depression of the point viewed is the angle formed by the line of sight with the horizontal when the point being viewed is above the horizontal level. That is the case when we down our head to look at the object. Example 1. A tower stands vertically on the ground. From a point on the ground, which is 15 meters away from the foot of the tower. The angle of elevation of the top of the tower is found to be 60 degrees. Find the height of the tower. Solution. First, let us draw a simple diagram to represent the problem. Here, AB represents the tower, CB is the distance of the point from the tower, and angle ACB is the angle of elevation. We need to determine the height of the tower, that is, AB. Also, ACB is a triangle, right-angled at B. To solve the problem, we choose the trigonometric ratio tan 60 degrees or cot 60 degrees, as the ratio involves AB and BC. Now, tan 60 degrees equals to AB upon BC, root 3 equals to AB upon 15. AB equals to 15 root 3. Hence, the height of the tower is 15 root 3 centimeter. Example 2. An electrician has to repair an electric fault on a pole of height 5 meter. He needs to reach a point 1.3 meter below the top of the pole to undertake the repair work. What should be the length of the ladder that he should use, which, when inclined at an angle of 60 degrees to the horizontal, would enable him to reach the required position? Also, how far from the foot of the pole should he place the foot of the ladder? Solution. In figure, the electrician is required to reach the point B on the pole AD. So, BD equals to AD minus AB equals to 5 minus 1.3 meter equals to 3.7 meter. Here, BC represents the ladder. We need to find its length. That is the hypotenuse of the right triangle BDC. Now, can you think which trigonometric ratio should we consider? It should be sin 60 degree. Therefore, sin 60 degree equal to BD upon BC. Therefore, root 3 upon 2 equal to 3.7 upon BC. Therefore, BC equal to 3.7 into 2 upon root 3 equal to 4.28 meters. That is, the length of the ladder should be 4.28 meter. Now, cos 60 degree equal to DC upon BD. Therefore, 1 upon root 3 equal to DC upon 3.7. Therefore, DC equal to 3.7 upon root 3 equal to 2.14 meters. Therefore, she should place the foot of the ladder at a distance of 2.14 meters from the pole. Example 3. From a point P on the ground, the angle of elevation of the top of a 10 meters tall building is 30 degrees. A flag is hoisted at the top of the building and the angle of elevation of the top of the flagstaff from P is 45 degrees. Find the length of the flagstaff and the distance of the building from the point P. You may take root 3 equals to 1.732. Solution. In figure, AB denotes the height of the building, BD the flagstaff, and P is the given point. There are two right triangles, PAB and PAD. We are required to find the length of the flagstaff, that is, dB, and the distance of the building from the point P, that is, PA. Since we know the height of the building, AB, we have tan 30 degree equal to AB upon AP. Therefore 1 upon root 3 equal to 10 upon AP. Therefore by cross multiplication we get AP equal to 10 root 3. By substituting the value of root 3, which is 1.732, and multiply it with 10, we get 17.32 meters. That is, the distance of the building from point P is 10 root 3 meters, that means 17.32 meters. Next, let us suppose dB equals to x meter. Then AD equals to 10 plus x meter. Now, in right triangle PAD, tan 45 degree equal to AD upon AP. Therefore 1 equal to 10 plus x upon 10 root 3. Therefore 10 root 3 equal to 10 plus x. Therefore x equal to 10 plus x minus 10 root 3. By solving this, we get the value that is 7.32 meters. So, the length of the flagstaff is 7.32 meters. Example 4. From a point on a bridge across a river, the angles of depression of the banks on opposite sides of the river are 30 degrees and 45 degrees respectively. If the bridge is at a height of 3 meters from the banks, find the width of the river. Solution. In figure, A and B represent points on the bank on opposite sides of the river, so that AB is the width of the river. P is a point on the bridge at a height of 3 meters, that is dP equal to 3 meters. We are interested to determine the width of the river, which is the length of the side, AB of the triangle, APB. In right triangle, APD, angle A equals 30 degrees. So, tan 30 degrees equals PD upon AD, that is 1 upon root 3 equals to 3 upon AD, or AD equals to 3 root 3 meters. Also, in right triangle PBD, angle B equals 45 degrees. So, BD equals to PD equals to 3 meters. Now, AB equals to BD plus AD equals to 3 plus 3 root 3 equals to 3 into 1 plus root 3 meter. Therefore, the width of the river is 3 into root 3 plus 1 meter.